This is a screencast of Unit 4, Lesson 10, Scatter Plots. I may have to film this screencast into two separate screencasts, me doing number 1 and doing number 2, because YouTube will only allow me to upload up to 20 minutes. So let's get started. This first problem says a box containing 1,000 coins is shaken and the coins are emptied onto a table. Only the coins that land heads up are returned to the box, and then the process is repeated. The accompanying table shows the number of trials and the number of coins returned to the box after each trial. We need to graph the data and then on the coordinate plane. So let's go ahead and get this graphed, and it's important to identify what's our x's and what's our y. So our trials are our x's and the coin return are going to go on our y's. So 0, 0 is still at 0, 0, even though we can only see the first quadrant of the coordinate plane. And it looks like on my x's, my minimum value is 0, which I already have. My maximum value is 6. So I'm going to go ahead. There's only 10 places for me to number. So I'm going to actually count by 1. So 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. And I won't have to use 7, 8, 9, and 10. And then let me make sure I write that those are the trials. Okay? On the y-axis, it's the number of coins. You'll have to forgive me. I do not write super well on Word documents. Alright, so my minimum value for my coins is 45, and my maximum value for my coins is 1,000. So I have 10 places to fill. So I think I'm going to count by 100, because 100 10 times makes 1,000. So 100, 200, 300, 400, 500, 600, 700, 800, 900, and 1,000. Now let's go ahead and get our ordered pairs on the graph. So 0, 1,000 is going to be up here. 1, 6, 10. It's going to be a little bit above 600. 3, 220. 4, 132. And then skip to 6 and 45. So you can see that this does look, this is called scatter plots, but it's also called exponential regression. So we're going to actually have the a graphing device, whether it's Desmos or a graphing calculator, write the equation of this exponential function. You see it curves around and heads approaching the x-axis as an asymptote. Alright, so that's me completing the first part of this problem, is deciding how I want to count my x-axis and my y-axis, and then getting the ordered pairs on the graph. The second part of this, it says write an exponential regression equation rounding the calculated values to the nearest hundredth. So to remind you what an exponential equation looks like, and I'm not going to write an h and a k, but it's y equals a times b to the x power. So I need an a value and I need a b value to represent this set of data. So to do that, I'm actually going to use Desmos. So I'm going to switch over to Desmos now, and I'm going to use Desmos to to have it give me my A and my B value. I'm going to go up here, and you can see this little arrow, drop down, and you want to add a table. Now in my table it's labeled X1, Y1. I'm going to enter my values. So I'm going to have to use the keypad on my for Desmos, but you can use the keypad on your computer. So it was 0, 1000, then it's 1, 610, and then it's 2, I take that back, it skipped to 3, and the Y with 3 is 220, and then 4, 132, and it skips to 6, and that Y value is 45. So I now have in my table, I'm going to hide my keypad, and I'm going to go to the second column, or row. In this row, I want to let it know that I am, I need it to write an exponential function for me. Let me, however, though, because we can't see any of my ordered pairs, that's because they're way up at like 1000. So if you go to this wrench, you can mess with exactly what you want your x value to see on your x value. So let's see, from -1, and my highest x value is 6, so let's go to 7. For my y value go from 45 to 1000. So let's go from 0, because I want to see down by the origin. And let's do a little bit above 1000, 1020. So now when I hide this, you can see here's my ordered pairs. I need the Desmos to graph or give me the equation that best fits this exponential data set. It's called exponential modeling. So I need to communicate to Desmos that I need it to do this. So I'm going to put in the generic exponential function, which is y. It's not y equals, because it's just going to approximate this equation for me. And to get approximate, you can either use your keyboard, and it's the button right next to 1. You have to hit shift and that button. But in the Desmos keypad, it's under the ABC, and you see it's the little approximate. And it is A. Oh, I take this back. Okay. The reason why I take this back is if you look at our function, or our table, it uses x1 and y1. So I actually need to put y1, then put approximate, and it's A times B. I need to raise that. You can use Shift 6 on your calculator. I'm going to use this A to the B. And again, my table uses x1 and y1, so I want to put, instead of just x, I want to put x1. And as you can see, it gives me, it draws the curve for me of that exponential function. Okay? And it also gives me what I need right here for my A and my B value. Okay, and that's what I need to write my equation. So I'm going to go back to the Word document, and I'm going to write down that A equals 1002.06 and B equals 0.60. Now if you use a graphing calculator, and on my JT Learn calendar on today's date there is a tutorial on how to use the graphing calculator to find this A and this B value. So this is from Desmos. For some reason you get a little bit different A and B value. So from the TI-84, I got A is 1018.28, and I got B is 0.60. So there's no difference in the B value. There's just a difference in the A value for some reason. So let's write these equations. So my equation for Desmos is y equals 1002.06 times 0.60 to the x power if you're using Desmos. And then for the TI-84, it's y equals 1018.28 0.60 to the x power. And again, if you go on today's date or the lesson 10 date on my JT Learn page, there is a video showing you how to do this on TI-84 or 83. All right, now looking down at the last question, it says use the equation to predict how many coins, so the coins are y, would be returned to the box after the 8th trial, and the 8th trial is x. So what we're doing is we're substituting 8 in for x, and then we are solving for y. So it doesn't matter, you're actually going to get the same answer regardless of what equation you use. So I'm going to use the TI-84 equation, and again we're substituting 8 in for x, and I get a total of 17 coins. I had to round. Okay. If you were to use the other equation, okay, you would get the same thing. And again, the trial number was our x value, so we're replacing our exponent x with 8. This guy would actually give you 16 point something. That would have you round to 17 coins. All right, that concludes the oops, sorry. If you saw a whole bunch of stuff on your screen, my bad. I don't know what I was clicking. But this concludes Unit 4, Lesson 10, Exponential Modeling. And I'm going to go ahead and film another screencast of me doing number 2. Please ask questions if you have them, and please watch the number 2 screencast also.